Assalamu alaikum warahmatullah. In example 3 of module 8, we will speak about timer interrupts. So we will use the same circuit that we used in example 1 and 2, and we upload this program, and I'm going to explain this program. So as you see, first we include the necessarily header files, IVR, IOH, and interrupt, and std boolean, okay, because we needed to do some operations. As you see, we have two ISR functions. ISR function 1 is taking timer 1 overflow as vector, and the second one is taking timer 0 overflow as vector. We are using the overflow of timer 1 and timer 0. If timer 1 overflows, that means it reaches its maximum, it will trigger the interrupt, and this will toggle bit 2 of port C. If timer 0 reaches its maximum, it will trigger another overflow, and the function will toggle bit 1 of port C. Now in the main program, the while true or the while 1 is doing nothing, so there is no main action, only the interrupt actions. We do only some preparation or initialization. So we make sure port C is output using the DRC. We give port C the value FF just as initialization. Now we need to enable the interrupt for timer 0 and timer 1 in TIMSK register. This is the value of the timer, so we set it to 0, so we initialize it to 0 because we need both timers to start from 0. Here the prescaler, so prescaler for timer 0 is 1024 and prescaler for timer 1 is 64. So this is done using the TCCR0 and TCCR1B. Okay, we set this value. You can go back to the first video speaking about timer interrupt, and I'm going to explain more about this when we speak about timers. Finally, don't forget to enable the global interrupt. So this is all the initialization to make sure the timer's overflow interrupt is working. When the timer will work automatically, and when it reaches its maximum value, it will trigger the interrupt, and the interrupt will drive port C, bit 2 and bit 1. So now let's move to the circuit and see how it will work. So this is the same circuit that we used in example 1 and 2. This time no need to use the buttons because we are not going to use the external interrupt. We will use the internal timers interrupt. So we will see the effects on bit 1 and bit 2. Okay, so we go to AVR Studio. This is the new program using the timer. We build it. Okay, after succeed, we go to the circuit and upload the new program, the hex file of the new program. Click OK. Then we run the simulator. So as you see, after running the simulator, D1 is blinking quickly because D1 is connected to timer 0. Timer 0 maximum is 255. So that's why every 255 it will change state. For D2, timer 1 is 16-bit, so it will take longer time to reach its maximum. That's why we see D1 is blinking faster than D2. So overflow will trigger the interrupt and will change the state of D1. Overflow of 16-bit again trigger D2. So as you see, there are difference in speed of the both timer because one is 8-bit, another is 16-bit. Okay, so what is running this LED is the interrupt function, which is triggered by the overflow of the timers. So we move now and show you the same circuit using the hardware. This is the implementation in hardware. So as you see, after I upload the program of the timer interrupt, you see LED 1 is blinking faster than LED 2. So the interrupt of the timer overflow will control LED 1 and LED 2. Thank you for watching and see you in next video.